Micron's $100 billion Mega-Fab in Clay, New York, a detailed report on current events and implications. Overview. Micron Technology's $100 billion semiconductor manufacturing facility, often referred to as a Mega-Fab in Clay, New York, is currently facing significant challenges that threaten to delay its progress further. The project, which is seen as a crucial step in bolstering U.S. chip production, is experiencing setbacks primarily due to environmental concerns and local community opposition. As of June 2025, the project's Environmental Impact Statement (EIS) has been postponed and the public comment period has been extended through August, meaning that construction cannot begin until local stakeholders provide their approval. Key issues and themes. 1. Environmental impact and community opposition. The delay in the Environmental Impact Statement is a critical aspect of the current situation. Community concerns regarding potential environmental impacts have led to a strong "not in my backyard" NIMBY sentiment among local residents. Such sentiments have been a common theme in other regions where similar semiconductor projects are proposed. For instance, Amkor's $2 billion facility in Arizona and SK Hynix's $3.9 billion fab in Indiana have also faced considerable local pushback, resulting in prolonged approval processes. 2. Financial consequences of delays. The financial implications of these delays are substantial. Estimates indicate that postponements can cost approximately $5 million per day for large fabs. This situation highlights the importance of the permitting process, as it has become a significant factor in the competitiveness of semiconductor manufacturing in the U.S. The lengthy approval processes in the U.S. stand in stark contrast to the speed at which projects can move forward in Asia, where construction can commence almost immediately. 3. Call for streamlining permitting processes. Industry experts are advocating for a restructuring of the site readiness approach. This includes bundling land utilities and environmental assessments before selecting sites for new fabs. Such proactive strategies could mitigate delays and provide a competitive advantage in the semiconductor manufacturing race. States like North Carolina, Pennsylvania, and Ohio are already creating megasites that address infrastructure and permitting needs in advance, making them more attractive for large investments. 4. Comparative analysis with other regions. The situation in Clay, New York, serves as a case study for the broader challenges faced by the U.S. semiconductor industry. The barren landscape of the Clay site, marked only by a coming soon sign, contrasts sharply with the rapid developments seen in regions like North Carolina, where Toyota's $14 billion battery plant was expedited thanks to preemptive infrastructure and permitting work. Current status and timeline of events. June 2025, the Environmental Impact Statement for Micron's Mega-Fab has been delayed with public comments open until August. This postponement means that construction cannot start until community approvals are secured. Background context. The CHIPS Act, established 3 years prior, aimed to revitalize U.S. semiconductor manufacturing by promising $52 billion in funding. However, the Clay site remains undeveloped, highlighting the gap between legislative intent and on-the-ground progress. Industry trends. The ongoing delays at Micron's site reflect a broader trend within the semiconductor industry, where local opposition and cumbersome permitting processes are emerging as significant barriers to rapid development. This contrasts sharply with the swift progress seen in Asian countries, where such projects can move forward without the same level of community resistance. Differences in reporting and focus. While various sources emphasize the delays and community opposition, they differ in their focus. Some sources succinctly report on the current status of the project, while others delve into the broader industry implications of these delays and suggest strategic recommendations for future developments. Additionally, some reports highlight the potential for future technologies reliant on semiconductor advancements, indicating a shift in focus towards the evolving landscape of technology infrastructure. Conclusion. Micron's Mega-Fab in Clay, New York serves as a critical example of the challenges facing U.S. semiconductor initiatives. The interplay between community concerns, environmental impact assessments, And the urgent need for infrastructure development underscores the delicate balance that must be struck to ensure progress in this pivotal industry. As the public comment period extends into August, the future of this ambitious project hangs in the balance, with significant implications not only for Micron but for the broader U.S. semiconductor landscape. The resolution of these issues will determine whether the U.S. can maintain its competitive edge in the global semiconductor market amidst growing challenges. Sources: 1. Semi-analysis Twitter //x.com/semi-analysis/status/1932586524379631888. 2. Semi-analysis LinkedIn //www.linkedin.com/posts/semi-analysis 3 years after the CHIPS Act pledged 52B activity 733-835-2698712276992 DQE7. 3. Semi-analysis company page //www.linkedin.com/company/semi-analysis. This comprehensive overview captures the critical developments surrounding Micron's Mega-Fab project and the broader context of U.S. semiconductor manufacturing challenges. Micron Technology's $100 billion semiconductor manufacturing facility in Clay, New York, is encountering significant roadblocks that reveal counterintuitive aspects of the semiconductor industry and its interactions with local communities. The project was initially hailed as a major step towards bolstering U.S. chip production capabilities amidst global supply chain challenges. However, the recent delays in the Environmental Impact Statement (EIS) and the public comment period extending through August are indicative of broader issues affecting not only Micron but the entire semiconductor manufacturing landscape in the U.S. Counterintuitive insights. 1. Local opposition versus national interest. While the national narrative promotes semiconductor manufacturing as crucial for U.S. economic security and technological leadership, local communities often resist these developments. This NIMBY not in my backyard sentiment is not unique to Clay, New York. Similar resistance has been observed in other states like Arizona and Indiana. This irony highlights a disconnection between federal ambitions and local realities. Communities may prioritize immediate environmental and quality of life concerns over the long-term national benefits of increased chip production. 2. Red tape as a competitive disadvantage. The idea that regulatory hurdles can act as a significant barrier to rapid development is not new, but the staggering estimates of financial losses, potentially costing $5 million per day, place these delays in a stark light. This suggests that the U.S. semiconductor industry is at a disadvantage compared to Asian competitors, who can often bypass lengthy approval processes. The counterintuitive takeaway here is that the very safety and environmental regulations designed to protect communities may inadvertently stifle the economic growth and technological advancement they wish to see. 3. Permitting as a strategic edge. The calls for streamlining the permitting process to create fab-ready sites suggest that the current approach to site selection is fundamentally flawed. The notion that proactive measures, such as bundling land utilities and environmental assessments, could mitigate delays presents a counterintuitive perspective. It implies that a more disciplined and forward-thinking approach to planning could enhance competitiveness, contrasting sharply with the reactive and often confrontational nature of current site approvals. For infrastructure investment perception, the juxtaposition of community acceptance of certain types of infrastructure projects like theme parks against opposition to semiconductor fabs reveals a curious dichotomy. Communities may embrace projects that promise immediate economic benefits or entertainment while resisting those that carry perceived environmental risks. This suggests a need for better communication and education about the long-term advantages of semiconductor manufacturing and its potential to drive innovation and job creation. 5. Misalignment of federal and local priorities. The CHIPS Act, designed to revitalize U.S. semiconductor manufacturing with a promised $52 billion investment, has yet to translate into tangible progress at the local level. The irony lies in the fact that while federal initiatives aim to streamline and accelerate domestic production, Local governments and communities remain entrenched in traditional approval processes that can significantly delay projects. This dissonance between federal goals and local execution complicates the path forward for major investments. 6. Potential for a broader industry shift. The struggles of Micron and other companies to secure necessary approvals could lead to a significant shift in how semiconductor companies approach site selection in the U.S. The emphasis on creating megasites with pre-approved infrastructure could become a model for future developments. However, the counterintuitive aspect here is that it may require a cultural shift among local populations and policymakers to embrace these sites, which could lead to faster approvals and investments. 7. Economic consequences of delays. The financial implications of these delays extend beyond the immediate costs. The notion that red tape is now the primary yield limiter in semiconductor production is a paradigm shift. This suggests that, contrary to traditional views focused on technological advancements and manufacturing efficiency, regulatory efficiency is becoming a critical factor in determining competitiveness in the semiconductor market. Broader implications. The situation in Clay, New York reflects a larger trend in the semiconductor industry where local opposition and lengthy permitting processes become significant barriers to rapid development. This trend is particularly concerning as the world faces increasing demand for semiconductor products driven by advancements in technologies like AI, automotive, and consumer electronics. As noted, regions like North Carolina, Pennsylvania, and Ohio proactively create megasites that preemptively address infrastructure and permitting needs. This proactive approach not only attracts investments but also minimizes the risk of community pushback. The comparison with other regions emphasizes the need for tailored strategies that account for local concerns while advancing national interests. In conclusion, Micron's Mega-Fab in Clay, New York, serves as a microcosm of the challenges facing the semiconductor industry in the U.S. The juxtaposition of community resistance against a backdrop of national economic strategy reveals complexities that policymakers must navigate. Addressing these counterintuitive insights is crucial for fostering a conducive environment for semiconductor manufacturing in the U.S., ensuring that local and national interests align for mutual benefit. Micron Technology's $100 billion Semiconductor Mega-Fab project in Clay, New York is facing significant delays primarily due to environmental concerns and local opposition. One aspect of this situation that many might overlook is the nuanced relationship between community engagement, regulatory processes, and the long-term viability of such massive infrastructure projects. Community engagement and NIMBY sentiment. The term NIMBY, not in my backyard, often oversimplifies the complex dynamics at play in community opposition to large-scale projects. While many may view local resistance as a barrier to progress, it is crucial to understand that these sentiments often stem from genuine concerns about environmental impact, quality of life, and the potential changes to their communities. The community's reluctance to embrace such projects can be rooted in fear of pollution, increased traffic, and alterations to the local landscape that they may perceive as detrimental. This is not merely a local issue, it reflects broader societal concerns about how industrialization impacts communities. Recognizing and addressing these fears is vital for companies like Micron to gain social license to operate. This requires a robust dialogue with stakeholders, transparency in environmental assessments, and a commitment to mitigating adverse effects. Ignoring or downplaying these concerns can lead to protracted delays and increased costs, ultimately jeopardizing the project's success. Financial implications of delays. The financial stakes involved are staggering, with estimates suggesting that delays can cost around $5 million per day for large fabs. While this figure is often highlighted, the implications of such costs are frequently overlooked. The semiconductor industry is highly competitive, and the ability to swiftly bring new manufacturing capacity online is crucial for maintaining market share. Delays not only increase the immediate costs of construction but also affect the long-term competitiveness of U.S. semiconductor manufacturing against quicker-moving projects in Asia, where permitting processes are often more streamlined. The financial implications extend beyond just the immediate costs. They impact investor confidence, stock prices, and the broader economic landscape. A project like Micron's is not just about building a facility, it represents a significant investment in the future of technology and innovation within the U.S. economy. Delays can therefore have ripple effects, influencing funding availability for future projects and the overall health of the semiconductor supply chain. The need for reformed permitting processes. The call for expedited permitting processes is a critical point that deserves more attention than it typically receives. The current regulatory framework often leads to lengthy approvals that stifle innovation and investment. Experts advocate for a proactive approach to site readiness, which includes bundling land utilities and environmental assessments before selecting sites. This strategy could significantly reduce delays and provide a competitive edge to U.S. semiconductor manufacturers. The comparison with states like North Carolina, Pennsylvania, and Ohio, which have developed megasites that preemptively address infrastructure needs, is particularly telling. These states have demonstrated that a streamlined permitting process can attract large investments and foster economic growth. The success of North Carolina in securing a $14 billion battery plant from Toyota illustrates the effectiveness of this strategy. The oversight in not implementing similar approaches for the Micron project may be a critical factor in its current struggles. Broader industry trends and implications. The challenges faced by Micron in Clay, New York are not isolated. They mirror a larger trend in the semiconductor industry where local opposition and prolonged permitting processes are emerging as significant barriers to rapid development. This trend is alarming, especially given the current geopolitical climate and the emphasis on strengthening domestic semiconductor production capabilities. As the U.S. strives to reduce its reliance on foreign semiconductor manufacturing, the ability to develop infrastructure quickly and efficiently is paramount. The delays at Micron's site could serve as a cautionary tale for future projects, highlighting the need for a balance between community concerns and the imperative for industrial growth. Conclusion. In summary, Micron's Mega-Fab project in Clay, New York encapsulates several critical issues that are often overlooked: the importance of community engagement, the financial ramifications of delays, the necessity for reform in permitting processes, and the broader implications for the U.S. semiconductor industry. Addressing these challenges requires a multifaceted approach that prioritizes stakeholder dialogue, streamlines regulatory processes, and recognizes the intricate relationship between local communities and large-scale industrial projects. Failure to heed these lessons could hinder not only Micron's ambitions but also the broader goal of revitalizing U.S. semiconductor manufacturing in an increasingly competitive global landscape. Here are the four most valuable points for in-depth analysis and discussion regarding Micron's $100 billion Mega-Fab in Clay, New York. 1. Permitting and community opposition. The delays in Micron's project are largely attributed to local community opposition encapsulated in the NIMBY "not in my backyard" sentiment. This phenomenon is not unique to Clay. Similar projects across the U.S. face resistance from locals concerned about environmental impacts, traffic, and other disruptions. The struggle for community approval highlights a critical barrier to expanding semiconductor manufacturing in the U.S. In-depth discussions could explore the dynamics of community opposition, the balance between economic development and local concerns, and strategies for effectively engaging with stakeholders to mitigate resistance. 2. Financial implications of delays. The financial burden of delays is significant, with estimates suggesting that such setbacks can cost approximately $5 million per day for large semiconductor fabs. This raises important questions about the financial sustainability of such massive investments and the potential repercussions for U.S. competitiveness in semiconductor manufacturing. A deeper examination of the cost structures and economic models involved in semiconductor projects could reveal how delays not only affect individual companies but also the broader industry landscape and national interests in tech independence. 3. Call for faster permitting processes. Experts argue for the need to streamline permitting processes and develop fab-ready sites that bundle necessary infrastructure and assessments before projects are proposed. This proactive approach could alleviate the delays currently plaguing projects like Micron's. An analysis of historical and contemporary examples of site readiness initiatives, such as North Carolina's megasites, could provide valuable insights into best practices. Furthermore, discussions could focus on legislative and regulatory reforms necessary to support expedited permitting without compromising environmental and community safeguards. 4. Comparison with other regions. The situation in Clay contrasts sharply with other regions such as North Carolina, Pennsylvania, and Ohio, which are successfully attracting investments by preemptively addressing infrastructure and permitting issues. This comparison raises questions about regional competitiveness and the role of state policies in fostering a conducive environment for semiconductor manufacturing. An in-depth analysis could investigate how these states have structured their economic development initiatives, the impact of state-level incentives, and the lessons that can be learned to improve conditions for similar projects nationwide. In summary, these 4 points encapsulate the critical issues facing Micron's Mega-Fab project and the semiconductor industry as a whole, making them ripe for further exploration and discussion. 1. The Boston Big Dig. The Big Dig was a massive urban construction project in Boston, Massachusetts that aimed to reroute the Central Artery I-93 into a tunnel under the city. While the project was intended to alleviate traffic congestion, it faced significant delays, cost overruns, and environmental concerns. Originally estimated at $2.6 billion, the final cost ballooned to nearly $15 billion. The project encountered numerous challenges, including community opposition, environmental regulations, and engineering difficulties, leading to years of delays before completion in 2007. The Big Dig exemplifies the complexities of large-scale infrastructure projects and the impact of local opposition and regulatory hurdles. 2. The California High-Speed Rail. Initiated in 2008, California's high-speed rail project was designed to connect major cities across the state with an efficient rail system. However, it has faced numerous setbacks, including environmental impact assessments, legal challenges, and community opposition. The project, originally estimated to cost $33 billion, has seen costs escalate to over $80 billion, with completion dates continually pushed back. Similar to Micron's Mega-Fab project, the California High-Speed Rail has been mired in lengthy permitting processes and local NIMBY sentiment, highlighting the difficulties of large infrastructure developments in navigating community concerns and regulatory frameworks. 3. The Keystone XL Pipeline. The Keystone XL pipeline was proposed to transport crude oil from Canada to various destinations in the United States. Despite its potential economic benefits, the project faced fierce opposition from environmental groups, indigenous communities, and local residents due to concerns over ecological impacts and climate change. Legal battles and permit delays plagued the project for over a decade, culminating in its cancellation by the Biden administration in 2021. The Keystone XL case illustrates the tension between infrastructure development, environmental protection, and community interests, reflecting similar challenges faced by Micron's semiconductor facility in Clay, New York. Future outlook for Micron's Mega-Fab in Clay, New York, and the U.S. semiconductor industry. The ongoing challenges faced by Micron Technology's ambitious $100 billion Mega-Fab in Clay, New York serve as a microcosm of the broader dynamics impacting the U.S. semiconductor industry. As the Environmental Impact Statement (EIS) has been delayed and public comment periods extend, the future of this project, and indeed the entire semiconductor manufacturing landscape in the U.S., is increasingly uncertain. Here we explore potential future developments and implications for the industry. 1. Permitting and community engagement. The ongoing delays highlight the critical need for a reformed permitting process. As community opposition, often characterized by NIMBY sentiments, emerges as a significant barrier, companies may need to invest more in community engagement and education. Future projects might see greater emphasis on transparency, actively addressing local concerns regarding environmental impact and infrastructure strain. This strategy could involve more comprehensive early-stage planning that includes community input before formal proposals are submitted. 2. Financial considerations and competitive edge. With estimates suggesting that delays can cost around $5 million per day, the financial implications of extended permitting processes cannot be overstated. Companies may be forced to re-evaluate their investment strategies, possibly leading to a shift in focus toward regions with streamlined processes and supportive local governments. States like North Carolina, Pennsylvania, and Ohio are already making strides by preemptively addressing infrastructure and permitting needs, making them attractive alternatives for semiconductor investments. 3. Strategic partnerships and collaboration. To mitigate risks associated with local opposition and lengthy approval processes, semiconductor companies may increasingly seek strategic partnerships with local governments and other stakeholders. Collaborative efforts to develop megasites that bundle necessary utilities, land, and environmental assessments could emerge as a preferred model. This approach could not only expedite the construction timeline but also enhance the overall attractiveness of projects to local communities. 4. Technological advancements and industry trends. As the semiconductor industry evolves, technological advancements will play a crucial role in shaping the future landscape. The rise of artificial intelligence, AI, and other advanced technologies will demand an increased supply of semiconductors. Companies that can navigate the current regulatory landscape and secure rapid approvals for new fabs will be better positioned to meet this growing demand. Future developments may also see greater integration of AI in the design and manufacturing processes, leading to enhanced efficiency and reduced time to market. 5. Federal policies and support. The federal government's role, particularly through initiatives like the CHIPS Act, will remain pivotal in shaping the U.S. semiconductor landscape. Future policies may focus on expediting permitting processes and providing incentives for local governments to support semiconductor projects. Enhanced federal support could help balance community concerns with national interests in bolstering domestic manufacturing capabilities. 6. Global competitiveness and geopolitical factors. As U.S. semiconductor projects face delays, international competitors, particularly in Asia, continue to advance rapidly. Future U.S. semiconductor initiatives may need to emphasize not only local community benefits but also national security and economic competitiveness as key arguments for support. The geopolitical landscape will likely drive increased investment in domestic manufacturing capabilities, necessitating swift action to overcome current hurdles. 7. Environmental sustainability initiatives. In light of growing environmental concerns, future semiconductor projects will need to prioritize sustainability. This may involve adopting greener technologies, utilizing renewable energy sources, and minimizing waste throughout the manufacturing process. Companies that can demonstrate a commitment to environmental stewardship may find it easier to gain community support and navigate the permitting landscape. 8. Long-term impacts on the workforce. As the semiconductor industry expands, there will be an increasing demand for skilled labor. Future projects will need to consider workforce development initiatives to ensure a steady supply of qualified workers. Collaborations with educational institutions to develop training programs and internships could become essential to meet the industry's evolving needs. Conclusion. The future of Micron's Mega-Fab in Clay, New York, and the broader U.S. semiconductor industry hinges on several interconnected factors, including community engagement, financial strategies, technological advancements, and federal support. As challenges such as local opposition and permitting delays persist, companies must adopt innovative approaches to navigate these obstacles effectively. By prioritizing collaboration, sustainability, and workforce development, the U.S. semiconductor industry can position itself for success in an increasingly competitive global landscape. The coming years will be critical in determining whether the U.S. can reclaim its leadership in semiconductor manufacturing or continue to lag behind faster-moving competitors.